Welcome back to database-tutorials.com, and do we have an interesting video for you today. In our last video, we learned how to use snippets to create database objects whose purpose was to minimize the amount of code you write by providing a basic structure of the statements for creating those objects, as well as many others. In this video, we're going to learn how to use constraints. We may have shown a few examples of constraints in a previous video where you can code them to restrict the values that can be stored in a table. Now we're going to go more in depth and gain a deeper level of understanding on how to use constraints. So let's get right to it. Hello everyone, and welcome back to the SQL Server Series. This video is brought to you in reference to Joe Marach's SQL Server 2016 for developers. If you're interested in purchasing a copy of this book, then please follow the link in the video description below. Constraints are used to validate data and to enforce referential integrity. Constraints can be used at the column level to restrict the value of a single column, or at the table level to restrict the value of one or more columns. Constraints are tested before a new row is added to a table or an existing row is updated. And then if one or more of the constraints aren't satisfied, the operation isn't performed. There are four types of constraints: not null, primary key, unique, check, and foreign key references. When using check constraints, it is evaluated as a Boolean expression, and if the expression is true, the insert or update operation proceeds. Otherwise, it'll just fail. So in general, you should use check constraints to restrict the values in a column whenever possible, but it is important to keep in mind that application programs that add and update data can also include data validation. So in this case, check constraints may not be necessary. A foreign key constraint is also called a reference constraint, which defines the relationship between two tables and enforces referential integrity. It typically refers to the primary key of the related table, but it can also refer to a unique key. The onDelete clause specifies what happens to rows in the table if the row in the related table with the same key value is deleted. The onUpdate clause specifies what happens to rows in the table if the key of the related row is updated. The noAction keyword prevents the rows in the related table from being deleted or updated and causes an error to be raised. And this is usually the preferred option when using constraints. So the first thing I'm going to do is I'm going to create a table. I'm going to call this one the invoice line items one table. And in this table, we're going to have some columns. The first one's going to be the invoice ID. It's going to be an integer column. And the constraint we're going to add on this column is going to be the not null constraint. The next one's going to be the invoice sequence. This one's going to be a small int. And then we're going to add in the not null constraint, which means any type of data you try to store in these two columns, it will not accept any null values. It will error out if you try to pass in anything that's null. The next one is going to be the invoice line item amount. That one's going to be a money data type. And we're going to say that that one is also a not null constraint. And then the next constraint we're going to use is called the primary key constraint. And we're going to list out two columns. One is going to be the invoice ID and the invoice sequence. That's going to be our primary key. So here we've just used two constraints. We've used the not null constraint to restrict null values from being stored into the invoice ID columns, the invoice sequence column, and the invoice line item amount column. And then we've used a primary key constraint to create a primary key for the invoice ID and the invoice sequence. So we're going to go ahead and we're going to create that table. That's that one. Now let's take a look at the check level constraints. Let's take a look at that. So the first thing I'm going to do is create another table. I'm going to call this invoice one. And then in here, of course, is going to be our columns. If I can get the words right. And we're going to say invoice ID int. We're going to use the not null constraint, and then we're going to use identity primary key constraint. We're going to assign the identity of primary key to that one. And then the next one's going to be the invoice total. That's going to be money. And then that's also going to be not null. I don't want to store any null values in there. And then we're going to use the check constraint. We're going to check to make sure the invoice total is greater than or equal to 0 when passed in to this column. And if it does not, then that check constraint is going to flag an error and it's not going to store it. So that's a constraint there. And then we're going to say payment total. This is also going to be the money data type, not null constraint. And then we're going to say the default payment total is 0. And then we're going to add a check constraint on that. And we're going to say if the payment total, as long as the payment total is greater than or equal than 0, then go ahead and drop in our data. So that's going to add in the payment total column. Let me just put a comma here where it belongs. And if we create that table, now we've got a table called invoice 1. It's got the invoice ID that can't store null values. That's a constraint. And it's been configured as the primary key of this table. And then our invoice total has a check constraint on it saying that you can't store any money data in this column that is not greater than or equal to 0. Same thing goes for the payment total. Now the difference here in payment total and invoice total is we have a default of 0 here. So it's automatically going to store 0 as the payment total if we don't pass in anything for the payment total. And then on top of that, it's going to check to make sure any data we try to store in this column is greater than or equal to 0. So that's 2 column level check constraints. Let's take a look at a check constraint that's coded at the table level. Let's create another table. Let's call this one invoices 2. And there's going to be some columns in here. First one's going to be the invoice ID. That's going to be an integer data type, and we don't want to store any null values in it. We want it to be our primary key. So we're going to set the identity as a primary key. And then we're going to create the invoice total column. That one's going to be, I'm sorry, not an integer, that's going to be a money. It's not going to be allowed to store any null values. And then we're going to move on. And there should not be a comma here. Just fixing that syntax error. Next one's going to be the payment total. This one's going to be money. We don't want any null values inside of it. And we want the default to be 0. Automatically passing the 0 for this column. And then now we have our check constraint that we're going to add in here. That's checking the constraints coded at the table level. So we're going to say check. And then in here, we're going to say as long as the invoice total is greater than or equal to 0, and the payment total is greater than or equal to 0, then you're allowed to add data into that column. So that's creating a statement with check constraints coded at the table level there. And so now we're just going to go ahead and end that and create that table. And that creates it. So now if we come back up here to the top and just kind of explain what we went over. We created a table called invoice line items 1 that had an invoice ID that can store integer data type. And then we added a constraint on it called not null. So that basically means that this will prevent null values from being stored in the column. We did the same for the invoice sequence, small integer data type, and the invoice line item amount. And then we added a primary key constraint on the invoice ID and the invoice sequence. So this requires that each row in the table have a unique value in the column, and no values are not allowed. The next table we created was invoice 1. This had an invoice ID of an integer data type. The constraint we added on there was not null. The identity was a primary key again, and we said we did not want our invoice total. We did not want any data to be stored in our invoice total column that had an invoice total greater than or equal to 0. So we put a check constraint on that. And that's a column level constraint that we added there on the invoice total column. We did the same thing for the payment total column. We added a check constraint here to make sure that no data can be inserted into this column that's greater than or equal to 0. And then we also gave it a default value of 0. So if we don't, you know, if we don't insert any data into this table for the payment total, it'll automatically pass into 0. Now down here, we changed things up a little bit. We still specified our invoice ID as an integer data type. We still threw on a not null constraint. And we still specified the invoice ID as our primary key. We identified it as our primary key. We did the same thing for the invoice total money data type. We said not null. And the payment total money data type, we said not null. But this time we just passed in a 0 as our default value if we don't pass in any additional data. Now, since our check constraint in this one is coded at the table level, we're doing a check here saying if invoice total is greater than or equal to 0 and the payment total is greater than or equal to 0, then data is allowed to be inserted into this table. So that's pretty much how that works, and that's how constraints work. Let's take a look at one more example here, and I just want to show you how it looks to try to insert data into a table that has a constraint where you insert the wrong information and it flags an error. So first thing I'm going to do is create a table. And this one's going to be called invoices 3. And then we're going to have our columns in here. First one's going to be the invoice ID. This is going to be the primary key. So I'm going to add the not null constraint on it. I'm going to set the identity to primary key. And then the next column is going to be the invoice total. It's going to be a money data type. It's also going to have the not null constraint on it. And then I'm going to add a check constraint. And I'm going to say if invoice total is greater than or equal, greater than 0, then you should be allowed to insert the information into the column. So now let's do a quick insert and see how it looks. Now remember, since invoice ID is our primary key and it's also flagged as our identity, it's automatically going to increment and create itself as long as we pass in an invoice total column. So I'm going to do an insert into invoices 3. Another way to do it is also just insert invoices 3. You can omit the into clause. You really don't need that anymore. And then we're going to add in our values here. And the value I'm going to pass in is -100. That's going to be for the invoice total. And if I insert that, oops, looks like I didn't create my table yet. Let me create my table. Okay, now I should be able to run the insert. And now we can see the insert statement has conflicted with the check constraint. And this conflict occurred in database master table dbo.invoices3 column on invoice total. And the statement automatically terminated. The insert did not work for us. And that's because we passed in a -100 into the invoice total column when the check constraint is on it to only accept an invoice total greater than 0. Now let's change it up a bit. Let's pass in 10 instead. Let's see what happens. Oh, well, now it accepts it. And so now if we were to select all from invoices 3, now we see our invoice ID, which is our identity column, automatically created a column for us in 2, and it stored our invoice total in there as 10 because it met the check constraint rules here. So that concludes our video for today. If you're interested in our next video, head on over to database-tutorials.com and also check out our YouTube channel. In our next video, we're going to learn how to drop indexes and tables from a database. So you definitely want to check that one out. So thank you for watching, and until next time.